welcome to everyone present here. The topic we are going to present in this PPT is Smart Irrigation for Enhanced Agriculture Production using IoT. The authors of this paper are G. Saranyadevi, Assistant Professor, EC Department, SRM Institute of Science and Technology, Ramapuram Campus, Chennai. Dr. R. Vani, Professor, EC Department, SRM Institute of Science and Technology, Ramapuram Campus, Chennai. And myself, A. Jeshron Sonali, EC Department, student of SRM Institute of Science and Technology, Ramapuram Campus, Chennai. S. Minovia, EC Department, student of SRM Institute of Science and Technology, Ramapuram Campus, Chennai. Content of this PPT are abstract, literature survey, introduction, existing system, proposed system, block diagram, hardware requirement, software requirement, advantages, disadvantages, applications, conclusion, future scope, and reference. In developing countries like India, agriculture plays a major role, and a smart sensor for controlling the environmental changes in areas where crop fields are grown is necessary for improving the productivity of the crop using less quantity of water as well as to reduce the complexity. This Raspberry Pi based IoT irrigation system has been developed. These environmental changes are controlled using IoT through simple message transfer protocol and message queue telemetry transport protocol having temperature sensor, moisture sensor, gas sensor and LGR, where information from all these sensors estimate the need of water to the field. MQT has high speed data transmission between the old data as well as the current data collected by the sensor, which are sent to MQT client. Literature survive. IoT-based smart crop field monitoring and automation irrigation. The main aim of this work is to determine the crop at low quantity water and well as to focus on water available to the plants at the required time. This was done by R. Nageshwara Rao. On the other side, the main aim of the work was to utilize the sensor in a paddy field and explain about WSN sensor application, and the results are implemented, and it will store the entire data in cloud and monitor and control using IoT. Now, introduction. The main factor for the agriculture is to predict the weather, climatic changes, and also to know that when these conditions are going to change. Here, both the automated irrigation system and the IoT is employed for the irrigation monitoring. It will be helpful for us to irrigate the crop or field at what condition the crop will able to sustain, and also to the other environmental changes to monitor the weather and climatic conditions which are varying with time and space. So the use of these electrical devices in the agriculture has been increasing rapidly. So the use of this WSN technology is applied to the irrigation systems, and it automatically removes high risk to the cable line due to the automatic operation of the machine. Due to the high cost of VSN system modules, we are not using this type of technology, and it also requires high energy for the data transmission between the client and the server. So, we will use the IoT, and with the help of IoT, we are employing the several systems in the different crop field by naming it as the clients, and this client which is getting reported every time to the server about the status of the crop, climatic changes of the temperature, humidity and also the moisture of the certain place, so that the watering and also when the pesticides can be served based on the conditions on the field. Existing system. In the existing system, all weather prediction and environmental changes are done manually, and then we are using WSN for communication. It is very slower than MQT, so that transmission occurs slowly, which may also cause collision when client is disconnected unexpectedly. Proposed system. In the present system, we are using the Crowfield algorithm, so the resulting data is having the high accuracy about the environmental, and also mainly we are using MQT instead of using WSN because MQTT is very much faster than WSN. We are using MQTT to transfer all the information about the climatic conditions, and it is processed automatically, like if there is any possibility of rain in the weather cloud, then the climate condition, the upcoming possibility of the rain data log, and also the current image of the environment will also be sent to the user's mail. These sensors send the data to the MQTT client. Whenever the client comes into the network, they will receive that data. This diagram clearly depicts how the entire process is going on. We are taking Raspberry Pi. In Raspberry input or output, we are connecting light sensor, and in LAN LDR sensor, and in USB moisture. We are giving the other end to the IoT sensors, and the output is directly initiated to the laptop or whatever system might be. And once the data is transmitted, it is directly entered into MQTT. Then it is analyzed, and then it is deposited to each and every client mail. Raspberry Pi. It normally evolved as a toy computer, and now it ends up here as a real desktop PC having an upgraded ARM v7 multi-core processor and gigabytes RAM. In general, Raspberry Pi has Mode B and B+, Mode A and A+, and Pi 0. They mostly operate in frequency of 800 to 1000 MHz. In extreme case, they have operate up to 1500 MHz. In this module, either USB nor Ethernet ports are changed. MQTT Protocol. The abbreviation form is Message Queuing Telemetry Transport. It is normally implemented in IoT. It is creating the massive machine-to-machine network so that all of the devices like sensor systems and also the actuators can connect to it and communicate it on the internet. This is a TCP or IP protocol. It is based on subscribe and publish messaging protocol, which is designed for lightweight machine-to-machine communication. MQTT has three stages. They are broker, publisher and subscriber. Now we are going to see about broker. Broker is also called as message queuing broker. It is like a gateway receiver or server and allows the client to send and also to receive the short message from the broker only if they have subscribed to any topic like weather, temperature and also the humidity. Publisher. The publisher is also called as the sensor, and this publisher has the information about the topic, and also this publisher has the data about the topic which subscribers have been subscribed earlier. It is connected to the broker by TCP connections. On all the sides, whenever the new data comes, it will be sent to the broker and also the publishers. In this MQTT, publishers allows username and password for the authentication, and these clients can directly log on using password. These passwords are sent by the MQTT via the plain text or in encrypted form. Subscriber. In this subscriber, it receives the filtered messages. Every message is being filtered by the broker, which is in the middle of the publisher and the subscriber. And it is also known that who will send the message and also who will receive the message. The subscriber is the application based. The broker filters the message based on the subject and the content based. And this also the type based filtered by the broker. The overview of MQTT. It supports the message in two types. Client which disconnect intentionally use disconnect message, and MQTT broker will automatically publish last will and the testament messages on the behalf of the clients with unintentionally terminated messages. It also supports the retain message which are automatically delivered when a client subscribes to the topic. The sensors used here are soil moisture sensor, temperature sensor and LDR. Soil moisture sensor. It senses the moisture content of the soil, and temperature, it will sense the temperature and operates from -55 Celsius to 150 Celsius. LDR is also known as light control resistor. When the light intensity increases, the resistance decreases. It can be used in circuits with light and dark activations, which are used for light sensitive devices. MCP3008 is a high performed and low power 10-bit ADC, that is analog to digital converter. It is used in the field of data loggers for multi-channel, robotics, medical field and smart sensor. Hardware requirement. Raspberry Pi, moisture sensors, temperature sensor, LDR, MCP3008, ADC IC, USB camera, SD card and monitor. Software requirement Raspbian Jas, PHP, Linux, Python, etc. The below figure shows the sensor parameters and also the weather conditions like temperature, moisture, humidity and also the amount of light which is receiving. It compares the data log with the already existing weather reporting conditions. It finds whether there is any possibility of the rainfall, then it will intimate to the user through the registered mail. It also predicts the parameters like thunderstorms, lightning, etc. If the figure shows the output for the MQTT subscriber or the client is receiving this value from the different types of sensor. The client or subscriber receives this information only when he subscribed to the broker. These sensor values are being sent to the client using the cloud and MQTT protocol. These parameters can be checked by the client through the registered mail. The advantages are speed is high, lowered operation cost, high security, no loss of the transmitted data, power consumption is very low for MQTT, battery consumption is low, MQTT recovers the old data. The disadvantages are complexity, maintenance should be handled with care. The applications are real-time information about the crops, it compares the real image with the existing image. Conclusion. In this system, the irrigation system becomes more simple and easy with the quick transmission of the weather parameters by using MQTT protocol and sending this data through cloud to cloud who has been subscribed. The main advantage of using this protocol is when the client is not available, then the parameters will be sent through the mail. When the client is available with the network, then he can able to see the data parameters and also he can compare the present data with the existing data which has already sent, so that farmer will be able to know the changes in the atmosphere every day. Future scope. This can be implemented by using the computer-based algorithm and also the data can be processed without any further complexity. With the other specification, sensors are used to make process better. Reference. IoT-based crop field monitoring and irrigation automation in Volume 4, Special Issue 19 April 2017. Automated irrigation using WSN and GPRS module. I-Transaction on Transmutation and Measurement Volume 17 2018. More field monitoring and automation using IoT in agriculture domain. IJCSNS Volume 15 Number 6 June 2015. Thank you so much.